30 kilometers off Shanghai, a port moves 14 million containers a year. Not a single worker on the dock. No accidents, no delays, no mercy. This is Yangshan, the ghost port, and it's quietly rewriting who controls global trade. A skyline of cranes, driverless vehicles moving in straight lines guided by software calling the next move. The work is mostly invisible, and this isn't a prototype or a midnight demo. It's a deep water hub built offshore, linked to the mainland, designed for the world's largest ships. When a facility like this saves hours, those hours don't stay at the waterfront. They move through supply chains. They show up as cost, availability, and price where you live. In this video, you'll see how China used engineering and automation to reshape global trade, and why ports half a world away are feeling the pressure. So how did an empty terminal, built 30 kilometers out at sea, become powerful enough to reshape shipping routes? To answer that, we have to start with the bottleneck that pushed China offshore. In the late 1990s and early 2000s, China's export machine wasn't just growing, it was compounding. More factories meant more containers, more sailings, and more pressure on the one part of the system that can't be stretched with overtime, the waterfront. Container shipping runs on standardized time. When the cycle slows, costs spread through inventory and production schedules. Shanghai sat at the center of that pressure. It had the manufacturing base, the capital, and the demand. But it also had a geographic constraint, the Yangtze River Delta. Rivers feed inland industry, but they also carry sediment, and sediment turns depth into a constant maintenance fight. At the same time, shipping lines were scaling up. Bigger ships lower the cost per container, but only if ports can process them fast enough to keep vessels moving. Ultra-large container ships need deep approaches, wide turning basins, and terminals designed for throughput. That's the origin of the ghost port idea. Remove the bottlenecks humans and geography can't solve fast enough, and replace them with engineered depth and engineered timing. Older terminals near the city had hard limits on depth and expansion. The shoreline competed with industry, housing, and road access. Dredging helped, but ships were getting larger faster than river-mouth infrastructure could adapt. China didn't just need more cranes. It needed deep water, predictable geometry, and enough space to design terminals like factories. So planners looked outward. Roughly 30 to 32 kilometers into the East China Sea sits the Yangshan Island cluster, rugged rock exposed to fog, wind, and typhoon season. The advantage was decisive. Naturally deep water, enough for the largest ships to berth without waiting on tides and without gambling on a silty channel staying open. The trade-off was obvious. Offshore, everything is harder. Materials cross open water. Crews work in violent weather windows. And even if you build the terminal, you still have to connect it back to the roads, rail yards, warehouses, and factories that make a port useful. That's why Yangshan was never just a port. It was a decision to rewrite geography. And it sets up everything that follows: the bridge, the engineered ground, and the automation that makes the docks look empty even when the system is running at full speed. The offshore decision only mattered if China could turn a few rocky islands into something that behaves like a modern terminal. Flat, rigid, protected, and connected to the mainland like it was always there. That's where the ghost port label stops sounding like marketing and starts sounding like a design spec. Yangshan is widely described as an $18 to $20 billion project. At 30 kilometers offshore, the sea adds cost to everything and punishes mistakes. The first requirement was a permanent lifeline. The Donghai Bridge stretches about 32.5 kilometers across open water, less a bridge than a supply route. Every container that leaves by road depends on it. During construction, every crane component and every load of material depended on it too. But access alone doesn't give you a port. You need a working surface. The Yangshan Islands were jagged and uneven, the opposite of what cranes and automated vehicles want. So engineers reshaped the terrain. Granite was blasted, peaks were cut down, the ground was forced into straight lines that could carry crane rails and vehicle corridors without drift. Then the project expanded beyond the original rock. Dredging moved seabed material to fill gaps, creating man-made land where there used to be open water. Reclaimed ground settles, compresses, and shifts as it searches for equilibrium. A traditional yard can tolerate small imperfections because humans adapt. An automated yard can't. If the ground moves, precision equipment loses alignment and minor errors become stoppages. So, engineers accelerated what nature would normally do over years. Vacuum preloading with vertical drainage pulls water out of soft seabed soils, forcing rapid consolidation so the ground finishes settling before heavy cranes and container stacks arrive. The logic is simple. Once operations begin, a major port can't pause to let the earth catch up. And then there's the sea itself. Yangshan sits exposed to fog, waves, and typhoon season. That's why breakwaters and seawalls are core infrastructure, built to dissipate wave energy and reduce surge so ships can berth and schedules don't collapse every time weather turns hostile. With the platform in place, the project moved to its real differentiator, making the port behave like a machine. This is where the ghost port is engineered. Remote-controlled or automated key cranes lift containers with repeatable motion. Electric automated guided vehicles handle horizontal transport, navigating with embedded references in the pavement, plus sensors and network coordination. The yard looks empty because the labor is concentrated in control rooms, maintenance bays, and the software layer that schedules every move. A conventional terminal relies on human judgment to absorb friction. A ghost port can't. Yangshan replaces that with design. Routes are defined. Work is sequenced by the terminal operating system. Container placement is decided by retrieval logic, not convenience. And that's what the cost really bought. Predictability, deep water, stable ground for automation, and a control system that treats ship time like the most expensive commodity on site. Because once a port can reliably erase delays, it doesn't just serve trade, it starts shaping it. That's where the ghost port stops being a Chinese infrastructure story and starts becoming an American problem. The United States doesn't lose to Yangshan in a single headline moment. The pressure shows up in turnaround time, yard velocity, and schedule reliability. In container shipping, a ship only earns money when it's moving. Hours at anchor burn fuel, crew time, and opportunity. That's why turnaround time is such a sharp weapon. Yangshan's automation is often credited with faster loading and unloading than traditional terminals, sometimes cited as roughly a 30% improvement. The gap that matters is not small. The difference between a mega vessel sitting for 2 days at a congested port versus leaving in around 15 hours is the difference between a global network that stays synchronized and one that loses its rhythm. American ports aren't incapable, but much of U.S. infrastructure is older and harder to expand quickly. Labor disputes, truck bottlenecks, rail constraints, and gate congestion can become system-wide delays. In that environment, a port designed from scratch as a high-throughput machine becomes an anchor point for the global schedule. That changes bargaining power. If shipping lines can depend on a few ultra-efficient hubs, they route capacity around them. That reroutes investment too. Warehouses, transload facilities, and distribution contracts follow the most reliable nodes. And when disruptions hit, pandemics, strikes, fuel shocks, the ports that recover fastest decide what moves first. The deeper shift is technological. Ports used to compete with cranes and waterfront length. Now they compete with software, data, and integration. If Chinese firms can deliver the cranes, the driverless vehicles, and the terminal operating system as a bundled stack, they're not just exporting hardware, they're exporting the operating model. Maintenance contracts, training programs, spare parts ecosystems, and software updates become long-term dependencies. That's how you end up with a phrase that used to sound abstract: the brain of global trade. Because in a ghost port, the brain isn't a metaphor. It is the scheduling logic that decides which container moves next, which lane is open, which crane gets priority, and when a ship is released back to sea. If the most advanced versions of that system are built, scaled, and exported by one country, the advantage isn't just low-cost labor or low-cost manufacturing, it's control of time. And once control of time becomes the advantage, the ghost port becomes a gravity well. Shipping lines build routes around places that don't waste hours. Over time, Yangshan stops behaving like part of Shanghai and starts behaving like a platform, one that other systems have to sync with. That changes what influence looks like. In a disruption, the hub that can keep moving decides what clears first. Critical components, empty containers needed to restart production, even time-sensitive medical cargo. Then comes the export layer. If China can sell the cranes, the automated vehicles, and the terminal operating system as one integrated stack, it can also export the operating model that comes with it. It's the same dynamic seen in smartphones or aviation, except here the device is a national choke point. You don't just buy equipment, you buy the operating model, and you commit to a long maintenance relationship. But a system this centralized also has a failure mode that old ports could sometimes improvise around. Imagine a coordinated cyber attack or a corrupted software update that freezes the ghost port's terminal operating system for 48 hours. Key cranes stop receiving safe move orders. AGVs lock in place to prevent collisions. Yard cranes halt because the container map can't be trusted. Ships stack up offshore, and the delays don't stay in China. They ripple into factory schedules, retail inventory, and contract penalties across continents within days. And that is why this port matters to American trade even when it looks quiet. The more the world optimizes around Chinese logistics hardware and Chinese logistics code, the more global commerce starts to run on Chinese assumptions about speed, scheduling, and control. Yangshan looks empty because the labor didn't disappear. It relocated into engineered ground that must stay level, into a bridge that cannot fail, into software that treats minutes like money. That is the real meaning of a ghost port. The absence is engineered, and the consequence is exported. Because once the dock becomes code, efficiency stops being a detail. It becomes leverage. This port doesn't just move containers. It trains the world to expect a new standard of speed, and it quietly punishes any country that can't match it. So here's the warning. The next supply chain shock won't be decided only by ships and cranes. It will be decided by who owns the schedule and who controls the operating system that releases the next vessel back to sea. If this changed how you see global trade, subscribe to Man-Made Marvels. Because the question isn't whether automation is the future. The question is who controls it. And right now, the answer is being written in Shanghai,